Hello everyone, this is Yogesh from ailuge.com. Today we're going to discuss about the LangChain components, and in that series we will discuss about the model component. In this model component, we will first discuss about the theoretical explanation of this to understand why it has been built, what is the use of the model component, and then we'll move to the practical implementation of the model component using Python and the LangChain framework. Let me go to my screen and share the agendas. So before moving to the LangChain model component, let's understand and recap the ecosystem and the components history, what we did in the last session. So in the last session, we understood about the generative AI frameworks and tool that is basically used to build a generative AI application from the scratch. Now, generative AI application is a package solution which is integrated using multiple components together. So on that, basically LLM provider is one of the component, orchestrator is one of the component, vector database one of the component, fine tuning and testing and monitoring. So it's a complete life cycle of the a generative AI application. Now in the LLM providers, you learned about OpenAI, Anthropic, Meta. Those are the big companies that provide the LLM models. Then orchestrators, we have a lot of orchestrators like LangChain, LangGraph, AutoGen, CrewAI, and we chose LangChain basically as our tool. Then we also discussed about the vector databases, because these are the databases which can store the embedding vectors and use for semantic search. Chroma, Fires, Pinecone, etc. were there. Fine tuning required because we need to train our model on a specific data set, specific domain. In that case, LoRa, QLoRa, PFT can be utilized. And finally, the testing part, where we need to understand the relevance of the model that has been built to basically benchmark against the KPIs. That's where the Langsmith, weights, bias, and Raga will come into picture. Finally, the monitoring and the deployment part, where the Docker, OpenAI, and a lot of other options are there. We're gonna use the Docker part. So this is the life cycle of any generative application. And in the LangChain components, we discussed about the core component, which is model, prompt, chains, memory, indexes, and agent. So in that, we will discuss the model component today in a very detail, and in the coming videos we'll discuss about each and every other component also in a theoretical and practical way. So moving forward, what is lang model component? So let's understand the component first. So component is nothing but a building block of any application. So when anybody asks what is component, it is a building block. It is a foundation, right, for any application or any framework to build. So model component is also one of the component in the LangChain, and the job of the model component is to stand. And job of the LangChain model component is to create the standard interface for the AI model, right? So it wraps multiple AI model all together to form a LangChain model component. And what does it mean basically? So take an example of any model called OpenAI GPT model, and let's suppose any other model is called Anthropic model. Now both of this model have a different schemas of the input, right? They might take the input payload in a very different way, input payload, and they can also generate the output in a very different way, right? Both the output schemas and input out schemas could be different. To solve this problem, LangChain has built a model component where these models are wrapped inside this model component. So let's suppose this is the model component, kind of a box, and inside this OpenAI is also there. Inside that, your Claude is also there, and many other models are there. And it takes the input in a one way. It converts what OpenAI needs according to according to Claude model and generate the output, right? Now output schema is also fixed. So what it does basically is kind of a wrapper which takes the input, adjust according to the model and generate the output, and also adjust the output also in the proper schemas. So basically you don't need to worry when you need to change the model, or maybe change the any building block of the component. And that's the model component basically use. Now to understand from an analogy point of view, consider a model component as an engine in a car, right? It's kind of an engine in a car, and in that LLM is like engine that generate the text. So LLM job is whenever you provide any query, it will generate the output. That's the LLM job. Embedding models are the such models which can generate the meanings of the words, which is kind of uh, two similar words will be together and based on their attributes. So that's the embedding model, and it is basically is kind of a new number vector of numbers, right? That's called the embedding model. Finally, the lang chain, right? So lang chain is nothing but a car chassis that can help you to swap engine, right, without changing anything while you are still driving. So you can change the engine, like let's suppose if you want to use the OpenAI LLM, you can use it. If you want to use Anthropic engine, you can use it. If you want to use Meta engine, you can use it. You don't need to worry about the whole structure of the car, because the car chassis, right, the lang chain is doing that job for the car. So that's the beauty of the lang chain, which wraps multiple things together to make the job for the developers very very easy. In one liner, if you need to understand what does your langchain model component does, it kind of create interaction between langchain, a language model, and the embedding models, right? So that's the job of model component. Now coming to the model component types. So in model, we will discuss about the two kind of models, which is the language model and the embedding model. And in language model also, there's a two kind of model, which is the LLM model and the chat models. So LLM models are those which are kind of ancient model at this point of time, because they are the very first generation of the LLMs, right? We'll discuss in a detail. And then finally there's chat models, which are the current model which we are using at this moment, like GPT-5. Those are the current generation models. Then what is large language model? So when LLM model came into picture, the job of LLM model was you provide any textual input and it will generate the text output. That's the job of LLM model. So they are kind of a model which takes a block of text together and then finally generates the output. That's the job. How they work basically, right? So they kind of, let's suppose you pass any text in English and ask them to convert in a French. Task can be done using the large language model at the very initial ages, like 3.5 GPTs and the Cloud 2. All those model were there, which is the very very initial stages of the LLM models. Now they were still significant. It's not like that they cannot do a lot of operation like summarization, translation, code generation, classification, any task which your general machine learning deep learning model could have done, or an LP model. Now it can be done using the LLM models. So that's the LLM model era. Now comes to chat model. So chat models are basically a specialized model which is wrapped around the LLM and designed to handle the conversational format, right? So in basically LLM model, the one thing which was missing was the conversational piece. It just takes the input and produce the output. It doesn't care about the who basically gave the input, for whom I'm generating the output. So there was no role based system, right? Now it has have a different role that can be assigned to the, along with the conversations, kind of a metadata basically, and then based on that it can produce the output. So let's suppose if you provided something based by AI message, it understand that okay, this is written by someone AI, and then if you give the role as a human, then it understand okay, the some human has given the feedback or maybe some chats, right? And based on that, it it can basically alter the output of the whole conversations. So that's the chat model right now. Right now, how does it work? It takes the list of messages as a chat message, and it also generates the object together, a structured chat object basically. That's the output of the chat model. Now, some of the important model in a chat model are GPT-4, Cloud, Gemini, OpChat, OpenAI. All those are the chat models right now, which you can use it. What are the use cases? They are used in chatbot, multi-turn assistants, agent, and whatsoever. Whatever you are using in a current in daily life, that's the chat model. Basically, we are using it. Right now, some basic differences. Although we discussed about it, but yeah, it can take the plain text string, whereas it can take the list of messages with the roles. Right, so we can assign really the roles of the messages in the chat model. Then it produces the text string, because the LLM model was built to give any text and generate the output as a text, whereas chat model can generate the chat message as an object. So basically list of chat messages can be passed as an input, and then chat message object can be generated as an output. Now, like we discussed, there was no roles, no history can be attained, whereas there's a built-in support for conversational roles. So you have like built-in memory also there, like for conversational memory, conversational buffer memory, that we're going to discuss in our coming videos, but those are already integrated in chat model. For one short task like translation, summarization, etc., LLM models were quite sufficient and good enough. Whereas for conversational app, chat, bot, agents, and a lot other advanced application, your chat model are basically equipped right now. So that's the basic differences between LLM and chat models. Now, coming to the video plan. So what we basically will discuss here, we understood about the model component. Now, in this model component, we have two kind of model, which is first your language model, and then second we have the embedding model. So in language model also we have a two kind of models again here, which is like LLM model, and then there is a chat models. So we will discuss about like in the chat model and the language model. There's a two other kind of approaches we can do it, which is open source and closed source. So in open source, we will implement it using the Hugging Face model, and in closed source, we will implement using the OpenAI, and there is a Google Gemini, and then finally there is a Anthropic cloud. So these are the closed source model. We will try to implement by all of this. Then in embedding also, there's a two kind of again approach, which is open source and then the closed source. So open source will use using Hugging Face, and closed source will use using OpenAI and Anthropic. Now in Hugging Face also, we'll have two option. First, we will see how to use the endpoints, and second, we will basically locally download the model and then run basically. So you'll see a local hosted model also and using the endpoint model also in embedding part. This is the whole the plan that will follow in in this complete video. Now, so first, let's understand the environmental setup. So before we move, we need to set up our system so that we can move forward. So for that, very first thing, we need to start with downloading the Python. So you can go ahead with, and once you go to the download Python, the link which I clicked it, you'll find it here all the versions of Python where you can install it in your system, right? So probably the latest version, stable version is 3.313.7, but you can also install based on your need like 3.11, 3.12. I think 3.12 is good enough to start with, but yes, it's up to your choice. Your system probably could be Windows, Linux, Mac, or Android, anything. So download according to your system. Once you download it, just right. So once the Python is installed in system, Python is installed, right? You probably need to check in the system whether your Python is really installed or not. So go to your terminal and type Python 3. So if you see this kind of messages, basically Python 3.12.7, that means your Python version is installed. If there is any error comes, then probably your Python is not properly installed. So you need to recheck it. After that, let's create a folder first, right? So let's suppose I created one folder, LangChain tutorial here, and in that folder, let's keep that folder blank right now, right? And open your Visual Studio Code. So you need the Visual Studio Code. If it is not there, just type in a Google right now, the Visual Studio Code, and again you will find like download option here. It is free, so you can use for Windows and the Mac or maybe your Linux application. Accordingly, you can download it here. Now, once you have the Python and the Visual Studio Code, create a folder. LangChain tutorial I created in my desktop, but you can create it anywhere and then import it here. So how to import? You go to the file, your open folder. So once you click the open folder, it gives the option, right, to select the folder, and you can choose accordingly. I just selected here right now. So once that is done, we need to update our virtual environment. Why we are doing virtual environment? Because we don't want to create a conflict with the global environment. So when you install Python, any version like 3.12 or 3.13, it will install in a root directory. Now in root directory, if you want to update any packages, it will affect directly to the root packages what you installed, but let's suppose you are creating two applications which might have a conflict in the package versions. It's not advisable to use the root directory, rather you create a virtual environment. To create the virtual environment, you just need to type this command basically. Let me just open my terminal and then start with. So currently I'm at root directory and right now I'm in my folder, right? So let me just type this command, which is Python. If you're not there in your folder, please move to your folder using this cd command, and then vnu, which is the env virtual environment, and give your virtual environment name. So let's suppose give test environment something, and it will create the test environment for me. So if you see, one folder will pop up here, right? Now the virtual environment is created, but we need to activate also, right? So source venv, and then venv. So once the virtual environment is created, we need to activate also. So for that, source and then virtual environment name, which is nothing but test environment here, and then followed by your bin, which is another folder here inside the test environment, you see, and then there's a function called activate, right? So type it activate. Yes, so now your test environment is activated, right? And if you want to just deactivate it, just type deactivate command. Same thing for window, just one change. Instead of bin, the activate function is present in the script folder. Okay, so now this is done. We need to install a few packages. If at this moment, if you just type pip list, it will be plain empty. There's nothing, no packages are there. So to install with the LangChain, we might need few packages. So let me install the few of the packages by one. So we'll install according to the need of the task, one by one. So pip install LangChain and LangChain OpenAI. So first we'll install, first we'll work with the closed source model, and then we'll see the open source model implementation as well. It will take a couple of seconds to install, and then it will be done. Okay, done. You can check again pip list, and you'll find all the packages which are dependent to LangChain. So LangChain 0.3 version is there, and then your LangChain OpenAI package is also installed. Okay, so now in our first model, which is the LLM model, we need to implement it. For that, let's create one folder. Let's call it one.llm. Inside that LLM folder, let's create one file. Call it like one.llm_demo.py, right? Okay, we forgot to install one more package, which is pip install. Let me just go there. And this python.env. Why this package is required? Because we need to keep the secrets of the APIs also. So it is advisable to keep it in some environment file, which is like .env file, and inside .env file all the secrets are present right now, all the tokens, because these are the access token. Without that your API will not work, right? Okay, so that is installed. Now let's just import LangChain. So first command is import LangChain, and then from LangChain _OpenAI import. So you see a lot of suggestions are there because I'm using GitHub Copilot, and OpenAI, right? So this is my inputs. I'll just want to check the LangChain version right now, whether my code is working properly or not. So let's move to the cd.1.llm folder. Let's see ls. Yeah, my file is there. Type it python and then one.llm.py. So if you just run it, yes, my LangChain version is properly installed and it is 0.3.27. Done. Okay, let me just import my secrets as well. So from .env import load env function. Now what it does basically, it will load all the environment variables whichever is required. So let's suppose that right now I'm using OpenAI APIs, and based on that it will set the tokens automatically. You don't need to put here like the token. Generally what we do, os.environment and then put the token, right? By mistakenly what happens sometimes when we push the code to git or somewhere, we forgot to remove that tokens and then we push it out here, so it exposes to the external world, which is not good. People might misuse that tokens on your behalf. So always keep a best practice to keep in an environment file. Now once that is done, okay, let me tell you how to create a token as well. So what you need to do, you need to go to the OpenAI website, platform.openai.com, do the login part, and then come to the project section. When we come to the project section, here there's an option called create. Once you open the create, there's a new create project also will be there, and then there's API key here. You come to the create new secret key, write the API name, I mean whatever name you want to keep it here, select the project. If you have created the project list will come. If I'm not created any project, default project will come, and then permission all, and then create the secrets key. Right now I've created, so I'm not creating it again, but this is my secret key, and copy paste in the environment file right now. So this is the environment file for you. Done. So post that, what you need to do is you need to invoke the models. So basically model equal to OpenAI. We are using the old model, so GPT 3.5 turbo, and you can also use like instruct model, right? Because those were the model which came very in early era, right? And then response equal to what is model dot invoke basically here. So invoke function basically used to invoke, call the model run function internally, right? We'll discuss more in a detail about invoke function, but right now understand it calls the run function of the model. So basically what is LangChain, and if you'll get the response, and just print this response and run again, save the file, done. So when you run it, here you see, so there's no information available about the company called LangChain, because this model was trained till 2021, right? And LangChain probably might have come after 2021. So let's type something. What is the capital of India, right? Something, and just rerun again. Yeah, here the capital of India is New Delhi, right? Because it has already been there from the long time, and that's the reason it is captured in GPT 3.5. Now, you probably not see this model because this model is already obsolete in the market, and nobody is using right now the LLM models. But why I'm showing it, because I just want to showcase like how the pre-era of chat models were there and what was the function of that. So the function is you pass any input in the string format and you get the response in a string format. So that was the job of the pre-era LLM models. Now let's move to the chat models. So let's create another folder again, which is chat underscore models. Okay, inside chat underscore model, let me just use chat underscore model underscore OpenAI, because right now you're using OpenAI APIs. Okay, the function is more or less same. You need to just use import LangChain from LangChain underscore OpenAI import. Instead of OpenAI now, you need to import chat OpenAI. So if you go to the previous example, here you have used OpenAI function. Now you're using the chat OpenAI because we want to use the chat models, which is the latest model right now, whatever we were using it. Again, from .env import load env function, because that's a requirement, and then load the model. So chat OpenAI model name. Here instead of 3.5 model, we can use GPT-4 basically, which is kind of latest right now. And then done. And again, save the results in response, print this result. That's all. And we are done. So let me just go back one folder back, and let's move to chat model. Type ls. Yes, it is there right now. Write python one dot chat model, and if you just run it, You'll see the response, the capital of India is New Delhi. Along with that, you'll see a lot of other pieces also. Why? Because the chat model do not just give the response, rather it gives a lot of metadata also. Probably at this moment, this metadata looks like a junk value to you, but this is very useful when you use the real time generative AI application using the LangChain. We will discuss more about these parameters, how to use it, and how it can basically help create a robust application. But right now, you understand that's the difference between the previous LLM model versus the chat model right now, what we are using it. There's another parameter here, which is called temperature. Uh, its value ranges between 0 to 1.5 on an average. So 0 means your more deterministic output. I mean, if you type like 0.2 or 0.3 something and you keep on iterating it again and again, you'll get a similar kind of output, the same query. But if you make it like 1.5, every time you run the same code, you probably get the different outputs, right? So that's the job of temperature. So let's suppose, let me just use what is, or maybe give me top 5 name of Indian male. Okay, so if I just run this, see, it gives the output of Amit, Rajesh, Suresh, Ravi and Vijay, right? Let me run again. So if I just run again, it again gave me Amit, Rajesh, Vijay, Ravi and Suresh, right? So there was not a lot of change, just Vijay has changed to Suresh, right? Now let me just increase this parameter, so 1 to 1.5 something, and let me just clear my screen once, clear, and run again. Okay, so now if I go to 1.5 and see the outputs, let's just wait for a couple of seconds. Yes, so Amit, Praveen, Vijay, Indra, now 2-3 people have changed, and if I just hit again, so Rahul, Amit, Suresh, Akshay, Ravindra, you see the variations, right? When we use the temperature value as a lower, it was more or less like one value changed, but when we use temperature 1.5, 2-3 values have changed in 2 iterations. When you hit again and again, it will keep on changing, so it will kind of put more, randomization in the output rather than just giving a simple output. So that's the job of temperature variable. Okay, now let's go to the another type of chat model, which is chat model from Anthropic, right? This is also a closed source model provided by the Anthropic company. So I'll just copy paste the code because it remains same. So instead of LangChain OpenAI, now I'm going to use it LangChain Anthropic. And instead of chat OpenAI, I'm going to use it chat Anthropic. And here also chat Anthropic. Copy paste. And in model, you can keep something like Cloud 2 or Cloud 3.5 Sonnet, whichever you can go ahead. You can basically go to the Anthropic website, and again similar way you need to create the APIs key. Unfortunately, I don't have subscription, so probably the code which I am running right now would not run. But here you can set the limits, you can recharge it. So like all these models are there, and probably I think $5 we need to pay for that as well. So you can use any of the model right now, like 3.5 Sonnet is there, then 3. Sonnet 3.7, then Sonnet 4, and all those models are there. So if I run this code, let me just ls, first save this file, and then if you just run python 2.chatmodel. Okay, so LangChain Anthropic we did not install, so let me just install it first. So pip install LangChain Anthropic, done, and again run it. Perfect. So it says 400 error because I don't have the subscription for the Anthropic. So again, this is just for showing purpose. If you don't have the subscription, you probably do not need to take for all. take for any of the closed source model. Either you take OpenAI or probably take from um, the Anthropic, right? And that will do your job. Now the third piece is from the Gemini, which is Google, right? So let me just showcase to that chat model gemini.py. Again, copy paste the code. So I'll just copy and paste it here. So instead of LangChain OpenAI, now here we need to write LangChain underscore Google underscore GenAI. This is the package name, and inside that the package called chat Google Generative AI. That's a package name, right? So just use this, copy here, and instead of model GPT-4 you need to paste like Gemini 1.5 one flash. Remove this temperature for now. Done. So probably we need to install this package first because it is not there. So let's install it. Pip install Google GenAI, and it will take a couple of seconds to install, and done. So we are good with the Google package also. So now let's just see the ls, okay, and Python 3-point chat model Gemini, and you just click it. It probably take a couple of seconds to run, and done. So you get the output here. So top 5 Indian male opportunities based on religion. So here a lot more other description before giving the name. So like Rohan, and then Aditya. So it also gave the description about why it chose Rohan or maybe Aditya or some other names, right? So that's the difference between the model to model. So let's suppose OpenAI model was direct answer, whereas Gemini was giving bit more descriptive answer to you. So that's the way you can use it. Now if you see here, there's a content variable inside the output, and the other response metadata is there. So if you just want to see the content, what you can do, response.content, save it, and then run again it. So, and if you just see the output, take a couple of seconds to generate. Fine. So now you do not see the metadata, just see the output, what you really need it basically from your side. So Rohan, Arjun, Aditya, Vihan, Aryan, so these are the names, top 5 names of the Indian male. Okay, so this basically covers our closed source chat model and LLM models. Now let's discuss about the open source model. So before we discuss to open source model, I'll first want to introduce you to the Hugging Face. Okay, and so in the Hugging Face, basically, what we need to do is we need to go to huggingface.com, and this is the website which basically contains all the models, open source model which is present right now. So different companies, individual who has created their open model has already put it out here. You can use it as much as you want. You can download it and you can use in your system as well. So it's free to use, flexible. Models are there, and a lot of categories are there here. So whichever model you want, if you want text generation model, you want text to video model, you can choose according to, you want based on libraries, you want based on apps. So a lot of filters are there, you can try it out. And then you also have a data sets. For fine tuning task, you might require some label data, and this data is also present here. So you can use this data and for fine tuning. We'll see that piece in the later videos when the fine tuning part will come. And then there's a spaces where you can create an application and deploy it here. So it's free to deploy the application also, and you can publicize to the open world, right, that we have created this application. Now to use the Hugging Face, we also need access token. So go to the access token, and we need to give the API here, confirm. Yeah, so here if you see LangChain token, which I have already created. So this is my token value, which we need to paste it in the environment file. Again, permission could be read, write, or both, or fine grained. Any permission you can give, but for now you can use the read permission. I think that's enough. Okay, Now let me go back and create the Hugging Face file. So fourth is chat underscore Hugging Face endpoint. Why I write endpoint? Because there's a two-way Hugging Face can be used. One is using the endpoints, just like we are using OpenAI, Anthropic, Google, Gemini. And the second way is we download the model in the local system and then use the model basically. So we're not calling the API, rather we are using the model which is deployed in a local system. So let's first see from the endpoint. So from LangChain, let's just import the LangChain first. Import LangChain from LangChain underscore Hugging Face. Now import your Hugging Face endpoint and then chat Hugging Face function. Chat Hugging Face. That's all. Oh, the spelling is wrong here. So this package is not there. Let's first install this package. So let me just clear it first. Pip install LangChain Hugging Face and done. So this package is installed. Again, load this load environment. Now, so to create the Hugging Face endpoint, there's one additional step what we need to do apart from what we used to do in the OpenAI functions and all. So let me just copy paste this code just to give an understanding, like here, and instead of chat OpenAI we give chat Hugging Face, right? But before that we also need to create our LLM function, which is Hugging Face endpoint, the library which we called, and here we need to give the repo ID. Okay, what is the repo ID? Repo ID is nothing but the model name. So if you go back to Hugging Face website and go to the model, so any of the model, if you click it here, let's suppose Google Embedding Gamma 300 million, this is the model rep name, or this is called the model repo ID. So whichever model you want to use it, you need to kind of give the repo ID. Just use it the Quan model, so which is Quan and Quan 3-8b, right? That's the model we are using right now, the Hugging Face. And also we need to provide what are the tasks we want to use it. So we want to use for text generation. That's all, right? So now this LLM, which is the model, will come here, and instead of model we can write LLM here. Model, we can just give the LLM here. Done. Okay, same, give me the top 5 name and done. And let me, okay, we saved it. Just see ls once. Yes, fourth model is there. So Pi 4.0, done. And it will take a couple of seconds, probably some more time as well, because we are now hitting the open source model. So it has some latency compared to your open source model. Yes, and we got the output. So again, you got here more different outputs, basically like popular in North and South India, Rohit, and then the meaning of it. So you see, right, the differences between the open source and closed source model. But ultimately what the end outcome is, the name of the 5 Indian male what we typed it. So that way we can use it the endpoints. Now let me just create 5th way, which is your Hugging Face local model. Okay, and that's, I think, local implementation. So we'll download one model and we'll try to use it, right? So let me just copy paste everything, logging chain. So instead of endpoint right now, we need Hugging Face pipeline. Hugging Face pipeline. Okay. Now, once we basically imported Hugging Face pipeline here, we need to create the same LLM structure, right? So instead of this uh, Hugging Face endpoint, now let me type, basically let's use this code, Hugging Face dot from model ID, and from model ID basically you need to provide the whichever model you want to implement here. Then also you need to give the task generation, and then there's some keyword arguments also there, right? So for now let's remove this keyword argument because we don't need it. And the model ID, we just want to use the very small model because we don't have the large infrastructure. Our system will not be able to run on the big models. So I'm using the tiny llama 1. So that's the model I'm using it. Okay, and the rest things remain same. We are just uh, calling this LLM here, invoking, and give me a 5 list. Let me just clear this, save this file, and then just do ls. Yes, the fifth file is there. So let me just use python fifth dot. Yes. Okay, so we don't have the transformer installed because that required transformer to be present. Let me just copy paste and install it, transformers. It will take a couple of seconds to install. Guys, even though it's very small model, but it will take a lot of time to run in your system because still it is 1.1 billion parameters, right? So now it's installed. Let me just go back and again try running it. Yes, I also need to install some of the packages, right? So let me go to the setup, and these are the packages which I need to install it because it is giving causal LM error. So it will take again some time. Okay, done. So it took quite a time, but it done. Now let me again try it running. Okay, so finally after 5 to 7 minutes, it gave the response. My machine is even though capable, but it took a lot of time. So that's the reason it's very difficult, to download any big model in a system and run it because it need GPU and all the high infrastructure setup. So that's about the chat models. Now let's go to the embedding models, right? Which is the second type of model in the modeling component. So let me create a folder called embedding, and inside embedding, let me just start with the open closed source first, which is like embedding OpenAI .py. And again the process will remain same, import LangChain, from LangChain underscore OpenAI embeddings is there. From .env load.env we need to import the secrets, and then instead of model now we need to import the embeddings basically. So OpenAI embedding is there. We can also define here model. So there are a lot of embedding models also present, like which is text embedding 3, small, medium, or maybe large. So accordingly you can choose it. And then once the embedding is imported, we need some query. So what is embedding basically? First we need to create the numerical representation of whatever query we write it. I mean in the numerical format, right? With the attribution, the meaning of the word also attached to that, basically the sentences. So that's called the dimension of the embedding. So right now if you just type like what is the capital of India, and then you need to convert into embedding. So let me just store in a vector because it returns a vector of numbers. So embeddings dot embed query. So instead of invoke function you need to write embed query function, and here you need to pass your query, and that's all. Just print the vector right now. Done. Save it. Let me go back to our third folder, which is embedding. So cd 3 dot, okay, there is no name have given, embedding. And if I just type ls, yes, it is there. So now run it, python 1 dot embedding OpenAI, right? So when that is done, you see this is the number which we got it, right? For a complete what is the capital of India. If you just print the length of this, which is length of vectors here. So because it has a dimension of 1536, so basically 1536 values will come. right, for one embedding, so that comes. But again, you can change the dimension here. So let's suppose dimension, I might need only 100 dimension, so I'll just keep it like 100 here, and then again try running it. Yeah, so now you'll see only 100 values instead of 1536 value, which is by default, correct? But this dimension option is only available for few models, not like all models support the dimension reduction, right? So we need to use very carefully this dimension one. So this is the embedding right now. The words basically converted to a numerical format, which is called the vectors, right? So that's embedding. Now let me go to the Hugging Face embedding, right? So how to use the open source embedding models basically. So again, we have a two-way, either we call the endpoints, or probably we can go ahead with the local model as well. But before that, let's just understand this is one query, right? Let's suppose I have a list of documents, then what I'll do it. So let's just use documents here and type it like New Delhi is capital of India, Mumbai is financial of India. Just two documents, that's fine. And instead of embed query now, here in the vector, embed document, basically you need to use it, documents, because we are using list of queries inside a list, all right, which is called a document. Now if you just print it, run this one, first save this file and run this, you see it's a big, basically two-dimension data you got it. So first is your for the first query, and the second dimension is for your second query, basically two list will get it. And the length of vector is right now 2, right? So if you just print length of vector of 0, basically the first query is length which is will be 100, right, and so on. So that's the way we can use the OpenAI embedding point. Okay, now let me go to the open source embedding using the Hugging Face. So let me create the Hugging Face file. Let me give 2 dot embedding underscore Hugging Face dot py. Right. There's a two-way which we can achieve it, either using the endpoints or using the local implementation. Let's see both way. So import LangChain. Let me just copy paste everything. I think it will be easy. And so from LangChain Hugging Face package, we don't need the chat endpoint embeddings, and probably I don't need these pieces right now. So load function and then Hugging Face endpoint here. I need to put it here. That's all. And just change this one. So the model basically I'm using is sentence transformer right now instead of your Quen model, because this is for embedding. And then remove this pieces we don't need, and then embedding dot embed query, because that's the function we are using for generating the embeddings for the query, right? So what is the capital of India? Let me just clear this piece and let me see ls. Yes, it is there. So in Python 2 dot embedding dot hy, and basically it will generate the output to me, right? So if you just want to print the length of result instead of only result, it will print you the result, basically length of the embedding. I think it is 768. So you might use the other embeddings which has the lesser dimension, but right now this shows 768. Again, you cannot use a dimension parameter for this kind of model because it does not suppose the squeezing of dimension by default. Perfect. So this is about calling the endpoints, right? Now let's go ahead and create new file, which is your local embeddings, basically the local way you can import the embedding models in your local system and then use it. So here, let me just paste everything here. So instead of Hugging Face endpoint, now you can use Hugging Face embeddings. That's all. and then you also need to provide the model name, basically which model you want to use it here. So for our case, we will use some of the smaller model because our system will fail otherwise. So here Hugging Face embeddings instead of Hugging Face endpoints, and the model name, here is the model name. Again, you can go to the Hugging Face website and you can choose whatever model you want to implement. Just make sure that it's not be big enough, otherwise your system will get crashed. So all the things will remain same. Let me just save this piece, clear everything, and let's ls once and see. Yes, we have a Hugging Face hf. So we need to change the name of the file because both are the same right now. It is, let's call it local. Perfect. Again ls. Yeah. So now let's just type python 3.local.py. Okay, so we don't have the sentence transformer. We need to import it because that's the package we are using right now. So just use this sentence transformer, pip install. It will take a couple of minutes to install. Okay, we are done, right? Now let's run again. It will take again couple of seconds to run. Perfect. It has created the embedding for me. And right now the dimension is 384. So I'm using the lowest model of this sentence transformer, which is the 384 dimension, right? Again, you can also use for the documents also, rather than just, so there's a one document, New Delhi is the capital of India, Mumbai is a financial, and instead of embed query, you can type something called embed underscore documents. Yeah, and save it and then run it again. Let me make it clear first. Perfect. And again it will take a couple of minutes to run. Perfect. It ran and it gave me the 384 two-dimensional array. Correct. So that's how basically we can use the embedding models and the chat models. Now let's come to the plan, and we discussed about the setup. We also understood about the implementation of both chat models. We also understood the differences between open source and closed source, because closed source model are freely available. They are, we can modify it, we can download it. It allows a lot more flexibility because we can fine tune it, we can use it according to our system. We probably can download in our system and do whatever things we want. Some few models are Llama and then Big Bloom, Falcon, but these are big models. Still we need to find some smaller model for our use case, and you see the platform called Hugging Face, right? For that, closed source model are those models which we can call using the endpoints. OpenAI, Anthropic, all those are the examples, and you do not have a lot of customization there. You need to check whatever the features they offer. There's some free tier model also there, like Google Gemini 1.5 Flash, but again it has limited features. So that's the trade-off between open source and closed source. Finally, we want to create one project, right? So what is the project? So we want to basically identify the similar document based on the user query. So let's suppose I have a list of documents, 1 2 3 4 5 6, like n number of document. It could be from any book or from any database or something, and there's one user basically here who gives some query xyz, and we need to match this query from this document and retrieve the most similar, whichever is the most relevant document, basically based on the query of the user. How we can achieve it? First, we get the document, we convert it to embedding, basically using the embedding document, right, and save this embedding here. Then we also need to convert this query also in the embedding, so the query embedding will be there. We need to use the similarity between them using the numpy. We'll create the similarity function, and finally once the similarity is there, we need to choose the maximum similarity score. Whichever is the maximum similar, we need to get it. So that's the job, and then finally we need to print. Okay, so now let's go back to the project, Visual Studio. Let me create a folder which is called capstone project hyphen similarity score, and then create a new file here. So create kind of project app.py. You can give any name, but yeah. So let's copy paste few things to make our job easy. Let me go to embedding OpenAI and copy and paste it here. So we are using right now OpenAI package to make sure that it takes very minimal time. Load .env function. We also need to import LangChain. We also need NumPy package, and we also need one similarity package, which is matrix.pairwise cosine similarity. We are using the cosine similarity to find the similarity between two embeddings. That's all. We can use this model, embedding 3 small. We can use the dimension 100 for now, and then let's suppose write something. What is the capital of India? And here let's suppose give some documents, like capital of India is Delhi, Mumbai is the financial capital of India, right? And capital of France is Paris, then Berlin is the capital of Germany, and then finally one more, something called your Dhaka is capital of Bangladesh. That's all right? So after that we will create one vector which is called query vector here. Perfect. Embedding.embed query, and then I'll pass my query, and this is my document vector. So I am basically getting the document vector also. So both the queries and the document now converted to your embeddings. Perfect. If you want to print something, you can print it. Now we need to find the similarity between them, right? To find the similarity, let's use some variable called similarity score equal to cosine similarity, and here we need to pass query and your embedding vector. Now remember, query vector is one dimension because it has just one single string, so we need to convert in a 2 dimension. How do we convert it? We can just use the list here. Inside list we can pass this query vector, so it will convert into 2 dimension, and document vector is already in a 2 dimension, so we don't need basically. Perfect. So once done, we can print the similarity score, and let me just clear everything here. Perfect. And ls, right? So I am right now not in the correct folder. Let me go to the project folder, which is capstone. Perfect. ls, and I could see here. Let me just use my Python command, Python project app, and we are done. Yes, so we are getting the similarity of all the 5 basically documents. So sorry, we forgot one comma. Again run it. Perfect. So now you see the similarity of all the 5 documents with your query. So query was what is the capital of India. So you see 79% it is correlated with your capital of India, right? And then the rest basically like 0.72 is the financial capital of India, because it also has a capital of India statement, right? And then 54 with the France, and then because it has a capital and elements are there, but more or less you have the max correlation with your, or max similar with 0.79, which is the capital of India, right? Perfect. So now I need to basically get the maximum score, right? So what I can do it, I basically use a numpy argmax function. What it does, it basically identifies the most maximum index for me. So np.argmax similarity score, if I pass, so this will give me the index where my document is present, the most similar document present, and then in my document I can reference using this index, right? So most similar document, and if I just print it, it will give me the most similar document. So I'll just run it again. Yeah, see, so right now it says 0.79 all the similarity score, and also it gives the document to me. So if I just want just one score which is more similar, I could just use a similarity score. Because it is a two-dimensional array, I need to use the slicing, which is 0, and then most similar index, which I got it already, I need to paste it here. And let me just comment this piece and run it again. And that's all, right? So New Delhi is the capital of India and 0.79 is the score. So that's the end of this session. I hope you have liked this session, and probably we can catch up in the next session for another intuitive tutorial on the other component, which is the prompt. So thank you so much. I hope you like this video. Please do subscribe this channel, do comment and let me know if you have any feedback, any errors are coming. I would be able to help you on solving this, and do implement something, and also let me know the GitHub of your project, whatever you implemented using model, embedding model, and the LLM models. Thank you so much. Bye bye.